Hey guys, welcome back to day 10. Today we're going to take what we learned about literal equations and we're going to apply them to some word problems. So starting with example number 1, the following equation can help you find the distance an object travels if it moves at a constant rate r for a period of time t in minutes. So our formula is the distance formula. Distance equals the rate times the time. So it says first to solve the formula for r. So what we did last class was we learned how to isolate that variable r, and we divided both sides by t. Okay, so r would be equal to the distance divided by the time. Okay, now we want to solve the formula for t, so kind of the same way. We've got distance equals rate times time. Now instead we're going to isolate t, so we need to divide by r, okay, because r divided by r is 1. So t would be equal to t divided by r, or d divided by r. Okay. All right, so first part says Kayla has 90 minutes to ride her bike before she has to be home for dinner. Write an equation showing the relationship between the speed she travels, the rate, and the amount of distance she can cover in that time. Okay, so knowing the rate and the distance, okay, we can say that the rate would actually be equal to the distance divided by 90. Okay. All right, so let's look at B. It's a clear day with a little wind, so Kayla figures she can average at least 0.35 kilometers per minute if she wants to be home for dinner. How far should she go before she turns around to come home? And explain. Okay, so she's driving out, all right, she's riding out, and then she wants to go out to a certain point and then come back. Okay, so we're looking to find out the distance that she can go out, all right, before she has to turn around. And she has 90 minutes, okay, to do the whole thing. So let's figure that to go out, she wants, if she's traveling at a constant speed, an average of 0.35, then she can go out for, say, 45 minutes. All right, so our distance is going to be equal to the rate times the time. All right, our distance is the rate she's traveling, which averages to be 0.35, and the time is actually going to be 90 divided by 2, or 45 minutes, because she's going to go out and come back. Okay, so if we calculate that out, we get 15.75, okay, and it's going to be kilometers. All right, so the reason is she can only ride out half the time since she needs to get back. So that would be our distance. Okay, 15.75 kilometers. So Kayla can usually average between 0.25 and 0.4 kilometers per minute. Complete the following table showing the total distance she can travel round trip for each average speed. So now we're round trip. All right, so that means it's going to be, she's going for 90 minutes. So if she's going at a rate of 0.25, all we'd have to do is our distance would actually be equal to 0.25 times 90, which we would get 22.5, okay? And that would be kilometers. Okay, and then we'd take for the next one 0.275, so the rate is changing, so the distance would be 0.275 times 90, and that would give us 24.75. Okay, and then 0.3 times the 90 would give us 27. 0.325 times 90, we're just multiplying, would give us 29.25. And 0.35 times 90 would give us 31.5. And 0.375 times 90 would be 33.75. And then finally, 0.5 times 90 would give us 45. Okay, so what do we notice about these? So for our input here, we have our as we're looking at our speed, okay, or our rate, it's increasing. So does the distance that she travels in 90 minutes. So as her speed increases, and that's the rate, so does the distance. The distance she can travel in 90 minutes. All right. Okay, so let's look at another example. Now we're going to talk about the size of nails, okay? The size of a nail is called a penny size, and it's given by this formula. D is equal to 4n minus 2, okay, where n is the length in inches of the nail. So we need to first solve the formula for n. So we do what we did last class, and we start out, we've got d equals 4n minus 2. So to solve for n, we're going to add 2 to both sides. So we get d plus 2 is equal to 4n. So then we divide by 4, okay? And we end up with d plus 2 divided by, so we've got d plus 2 divided by 4 is equal to n. Okay, we can also write that as n is equal to d divided by 4 plus 1/2 if we simplified. Okay, so if we had a penny size of 5 and we plugged it in here, okay, d plus 2 would be 4 plus, we'll write this as 5 plus 2 divided by 4, which gives us 7/4, which is 7/4 would be 1.75. Whoops, write it down here, 1.75. Okay. All right, and that would be in inches. Let's change that. That should be in inches right there. That should be IN. Okay, so for 12, again, we're going to plug it in. Now we've got 12 plus 2 divided by 4. So that's 14/4, which is going to be 3.5. Then we're using that same formula to have an input of 16. So we've got 16 plus 2 divided by 4. So we get 4.5. And then 20, okay, we've got 20 plus 2 divided by 4 would give us 5.5. Okay, so that would be 22/4, which is 5.5 in inches. All right. Okay, so let's look at number 3. The formula for finding the volume of a cylinder is V is equal to pi r squared h, where r represents the radius and h represents the height. Using the formula, find the equation that can be used to find the height h of the cylinder. So all we're doing in this word problem is solving for h. So if we have V is equal to pi r squared h, it looks complicated, okay? But we're isolating the variable h, we can actually do it in one step. All we have to do is divide by pi r squared. Okay, so pi r squared divided by pi r squared would go to 1. So we're left with just h. So h is going to be equal, I'm just going to switch the order, V divided by pi r squared. There's our answer. Okay, the formula for finding the area of a trapezoid is A is equal to 1/2 h times B1 plus B2. Okay, solve for h. Now be careful, okay, the trapezoid, B1 and B2, these are separate variables, okay? B1 is a variable, it's base 1, and B2 is a separate variable, V2. It's not an exponent, it's a subscript, it means it's a separate variable. So if we're solving for h, we're going to start by getting rid of that fraction 1/2 and multiply both sides by 2. So if I multiply 2 here and 2 here, I end up with 2a is equal to h times b1 plus b2. Okay, again, we're multiplying by 2 because if I take 1/2 times 2, I get 2 over 2, which is 1. Okay, so that's how we cancel out the 1/2 and the 2. All right, so we have the h left. Whoops, not the 1/2. Let me erase that. We still have an h, so we just canceled out the 1/2. Okay, all right, now, all right, we're solving for h, so all we have to do is divide both sides by b1 plus b2. Okay, so whatever we do to one side, we do to the other, and they cancel out. We're left with h is equal to 2a over b1 plus b2. Okay, it's all divided by. Okay, that's our answer. All right, moving on to number 5. The equation of a line is represented by y is equal to mx plus b, where m represents the slope and b represents the y-intercept. What is the equation that would be used to find the y-intercept? Now be careful, it's not the variable y, okay? The y-intercept is actually the b, and we're going to be using this in the next couple of weeks, okay? So we're solving for b. So y equals mx plus b. And since we're solving for b, it's actually a very easy problem. All we have to do is subtract our mx from both sides. Okay, so when we do that, it would cancel us out there. We're left with y minus mx is equal to b, or we write it as b is equal to y minus mx. There's our answer. Okay, now the last one we have here, it says the formula to convert between Fahrenheit and Celsius is F is equal to 9/5 C plus 32. Find the formula if you're given a Fahrenheit temperature and you need to find the Celsius. So what we're doing is we're solving for C. Okay, so I'm going to write the problem down. F is equal to 9/5 times C plus 32. Okay, so to solve for C, the first thing we need to do, okay, oops, actually let me erase that, sorry. Got a little ahead of myself here. Let me rewrite the problem as is first. F is equal to 9/5 C plus 32. Okay, so the first thing we're actually going to do, since we're solving for C, is we're going to subtract our 32. Okay, when we do that, on the left we have F minus 32 is equal to 9/5 C. All right, so to get C by itself, we really want to divide by 9/5, but that's the same as multiplying by the reciprocal. So if I took 9/5 and I took the reciprocal, it would be 5/9. Okay, and if I take 5/9 times 9/5, I get 45 over 45, which is 1. Okay, so I'm going to multiply both sides by 5/9. When I do that, that causes the 9/5 times the 5/9 goes to 1, and we're left with C is equal to 5/9 times F minus 32. And it's important that you put the F minus 32 in parentheses because the 5/9 needs to be multiplied by the whole side. Okay, so I hope that helped. I think that was our last example. Yep. All right, I'll see you later.